Hi everyone, Gwen Shapira here for the SaaS developer community where we learn about SaaS. And today I want to talk a bit about Reverse ETL, and the reason I want to spend a few minutes talking about it is that this morning I talked with a very smart friend who was in the ETL space for decades, and he said, yeah, I've heard about Reverse ETL, but I don't get why are people making such a big deal out of it. So I figured if this guy didn't know, I'm sure a lot of people heard the term and don't understand the hype. So I hope to quickly explain the hype. Why is Reverse ETL such a big deal? So as a reminder, we have good old school ETL, where we take data out of our production databases. Sometimes we call them OLTP databases, online transaction processing. We take them out, we manage them, and we load them into our data warehouse and our analytical systems. Why do we need to do it? Because these two different systems were written in very different ways. OLTP were written for data access that favors very small chunks of data, like a single employee, a single product. I just bought one pair of shoes. This employee just logged in and started working. It's very small data, and that's where we're talking about millions of those tiny transactions happening per second. Data warehouses, on the other hand, they analyze very large batches of data and do rather complex analysis. So it's not one person bought one pair of shoes in this point in time. It is how many shoes were sold this quarter versus the same quarter last year. Is it more of them in Asia versus North America? Is there some trend? Which type of shoes are trending? Any customers who bought shoes 3 times the previous quarter but didn't buy any pair right now? So we're talking about things that are far more sophisticated analysis. And the different databases, really literally from the hardware up, are built in very different ways of indexing, different memory layouts, different disk layouts, different types of disks, different types of network. Everything about those two types of databases is very different. So we had to take data out of one system, manage it a bit, get it into the other. One of the reasons you need to do the managing is that the schema is very different as well. OLTP tends to be third normal form. Every entity in the world is really in its own table. So you have employees table, but then, like, for example, you may have if an employee could have multiple addresses, you would actually have another table just for addresses and tie it into the employees. So it's very, very normalized. Data warehouses, on the other hand, you usually have this thing called the star schema, where you have a very big fact table with literally everything that happened. And then those facts have dimensions to them. So who did it, when they did it, where they did it, why they did it. And those dimensions are typically in their own table. So it will be like employee ID, is related to that fact, and the details about the employee will be separate. The dimensions typically change. Employees may change the role. And there is a lot of interesting things. If the fact was recorded 10 months ago when the employee was in one role and then they changed the role, how do we keep track of the employee history and join it together? So that was kind of like data modeling 101 in about a minute. So here we are, we have ETL. Reverse ETL, as you can imagine, is exactly the reverse. Taking data out of the data warehouses into those production systems. Now, you may ask yourself, why in the world would anyone want to do that? And the reason is that the data warehouses is usually where you have really interesting insights about your customers that are not available anywhere else. Part of it is because the data warehouse don't just have data from one production database. It has data from multiple production databases, from the sales, from sales, from marketing, from the actual production products. All of this is coming together there, so you can really have the Customer 360. It's kind of mythical. Not people will debate if anyone ever has Customer 360, but the closest you get to that in the data warehouse, where you can say things like people who signed up to our product after meeting someone at this conference, and then they did those specific actions in the product, and then they stopped doing them. This is sophisticated analysis that is over a long period of time and requires data from multiple data sources. So this usually will exist only, and in the good case, it will exist in the data warehouse. It very rarely exists anywhere else. But as we move toward a world with product-led growth, you want these insights in the OLTP production database, so the product, the UI, can actually show things that are relevant based on this data. So if a person signed up after they saw you in this specific conference, you may want to show them links to other talks that happen in this conference, things that are more relevant, more interested, trying to make the product more engaging, maybe more educational. There was a good presentation on this channel by Laura Brockman, who kind of explains that the biggest challenge is that she really wants to make some recommendations in the product to people who used KSQL, a specific feature of the product, a week ago, used it once or twice, but then didn't touch its sense. And she wants to remind them that it exists and maybe convince them to come back. She needs this insight. They used it once or twice, never came back to it. And so she really needs this data from data warehouse in her production database. So now that we know that it's a big deal because it can unlock huge growth and engagement and activation for the business, why is it hard? We can already only do, that's what my friend said basically. We can already do ETL and it's just the same thing. I'm just reversing the arrows. What could possibly be so hard about it? Well, one thing is that the data doesn't just go into one production database. It will go into many things that are part of the day-to-day life of the business to an extent that it feels like a production database. And if you look at the world maybe 2 decades ago, before the cloud and SaaS was a big deal, those would have been production database. It would have been your Sybils and your SAPs and all those really big operational systems running on production databases in your on-prem data center. Now a lot of it is all SaaS, of course. There's the SaaS CRMs, the NetSuite, all those things are running as services, marketing services, etc. So they all need these really deep business insights from the data warehouse. So you really have to kind of send it to a lot of different systems. Some of them are not databases, so you have to figure out their APIs. So it's actually a lot more complicated than that. But let's say that, okay, sending things to different systems is just a bunch of connectors. So really, we already have connectors. Why is that such a big deal? And this is a big deal because, well, there's 3 reasons. First of all, technically speaking, reverse ETL is an extremely unnatural thing to do. What do I mean by that? Remember that I explained that OLTP typically does things in tiny chunks that happen very, very fast, many times per second, and it's built for that. And a data warehouse is traditionally built for large batches of data processed together in interesting ways. Among other things, it also means that data in production happens continuously. Data in data warehouse usually happens in kind of batches, and every day, every hour, and so on. There's a lot of reasons why you want it to be that way and why it is this way. So you basically saying, I want to take data from somewhere that comes in large batches and push it into a system that needs a lot of very, very small inserts, and that really anything that is too big is risky, because the one thing you really don't want in your production system is to slow things down because you are doing something big on the system. You don't want a user request to get stuck behind a queue, like a CPU queue, behind a huge processing or a large load, or the disks suddenly get overloaded and everyone has to wait, this will impact your production experience. So you're basically asking a system to do something that it was not built to do, and it's on both sides. Like the data warehouse was not built to take data in continuously out of it. It was built to process data in it and show it like in summaries, a nice report. You're not supposed to just pull out every single data point. And the OLTP database was not meant for loading massive chunks of data to it all at once. So you have to solve technical challenges because you're going against the grain. And I talked about it a lot. If you're building software architectures, everything that you do that goes with the grain in the way that is natural for the system, it's easy, it will perform well, it will just feel good, it will be easy to run it in production. Things will not mysteriously cause problems. If you do something against the grain, you're typically up to a lot of pain. So reverse ETL has to happen carefully. The second thing is that organizationally, the data warehouse is not always owned by the engineering teams that own production databases. So a lot of time the data warehouse is really not maintained and managed with the level of care that today, after many decades of running things as services, we know to apply to production systems. There is whole disciplines about continuous integration, about testing, about how do you maintain production systems and make sure that they don't break, how do you fix things when they do break. Like there's, SLAs, SLOs, those are usually very foreign to people who maintain large data warehouses in organizations. Data warehouses do not have to be up continuously. People actually go in and on occasion apply large schema changes, and things that you would never imagine doing in a production database actually happens not infrequently in data warehouse, because data warehouse, the only thing that really matters is generating those insights. And if you need to go in and hack some small changes in order to make sure that the CTO gets, or CIO or CFO gets their big reports 8 a.m. on their desk, nobody cares how the cake is made. In production, databases are very different. Now imagine a world where you get stuff from the data warehouse to production, and this is part of the product experience. You need this data to be fresh, otherwise you're giving users bad recommendations, useless insights, the tips, the hints, all the nudges, like all the work that they made to really gently push the right users to do what you want them to do. It will no longer work if the data from data warehouse stops showing up or shows up wrong or not fresh. So you need to start applying a lot of discipline to the data warehouse and obviously to the ETL systems that gets things from the data warehouse to the production database. This is a heavy organizational lift. In many places, the owners of data warehouse, being data science, business analytics, all those things, they report to finance, they report to marketing, they report to CRO, all those places where it's not engineering and they don't have the same engineering disciplines that most organizations have these days. So it will be interesting. Do you move the ownership of the data warehouse now that it's in production, but then engineers have to start service business units that previously didn't really have this relationship? Or you end up imposing engineering discipline on the owner of the data warehouse, which will again increase their level of friction. They may struggle to be as responsive to the business as they were before because they have to maintain higher discipline. Fascinating questions that I think we will just have to wait and see how the world shapes up. Now, the last challenge is that, practically speaking, the tools are not quite there. So remember we said, hey, we're taking data out of this thing, we're pushing it into the other thing. It's just the same thing in reverse of something we're already doing. How hard can it possibly be? But if you think about it, the state-of-the-art tools that we currently use for a lot of our ETLing, the change data capture, all of those, they were actually developed and tested with one direction in mind. So there's a lot of tools out there that know how to take data out of Postgres and load it into BigQuery. I don't know that there is a lot of tools who know how to do the reverse. I don't know that anyone knows how to do change data capture to BigQuery. I don't know that anyone solved the problem of really efficiently and reliably loading data into Postgres without impacting the rest of the production loads. Like, those are actually problems that we didn't really visit before. How do you very reliably and continuously load data into HubSpot? What happens if the batch is really large? Like, there's just all those problems that we haven't thought of before. And as we all know, if you have something that has to work incredibly reliably, and there aren't like 2 decades of discipline around how to do it really well, there is a chance that you're not going to do it very well for the first 2, 3, maybe 5 years. So this part is going to be very exciting for the people who are going to do it. So you can see that it's, if I have to summarize it, reverse ETL is big because it's high risk, high reward. The stakes are high. It's literally about your ability to grow the business in a much more competitive way. And the risks are high because even though it sounds like it's something we've been doing all along, it's actually an incredibly new technological area that people have to navigate. So when it will not surprise you to hear that the person that I had this fascinating conversation with is someone who is very much into streaming ETL and streaming databases. And we both concluded the conversation with the understanding that this is actually a really big opportunity for streaming ETL. Streaming ETL is something that I was involved with for many years now. And one of the challenges that we've always had is that there's obviously a learning curve. There's obviously streaming ETL is something you have to learn, you have to adapt to, you have to know how to debug. Yes, you just write SQL, but it's we're sometimes thinking in batches of a single day is so ingrained in us that we have to shift a lot of our thinking around what do we do when it's continuous, when there is not, okay, we'll load a batch and then we will validate it and then we'll say everything is good and then we'll move on to the next thing and then we'll generate a report and the report only covers things with the batches before it. All those things are a bit more amorphous and we have to shift how we think about them. So obviously it's a challenge. And the problem always was that it wasn't clear what do you gain from this challenge. So yes, maybe you will get your data warehouse insights continuously and not every hour, but is there anyone really waiting for those business data warehouse insights continuously and not every hour? Like, people may only look at them once a quarter or once a week, but now that in reverse ETL, if you think about it, you need those insights at a production system rates, essentially. You need them to be there at the right time for the right user to push them to do the right thing. So it's much more real time. You never know exactly, you need the right data when the user is in the system, when he's clicking around, when he's trying to do something. So there is an urgency finally to get those insights to someone's hands at a much more continuous basis, because the users don't just log in at the end of the week and the end of the quarter. They look around the product all the time. But I think more importantly, remember that I said that technically speaking, ETL is unnatural because data warehouse works in batches and your production works in streams. Turning a stream into a batch is fairly easy, right? You just wait a bit and then you read everything that you missed and then you shove it somewhere else. This is easy. Turning a batch into a stream is actually more challenging. You have to kind of slice and dice it, be continuous about it. You need to treat your data warehouse almost like a queuing system. And the nice thing is that event streaming platforms have been really bridging the request response super real time to batch gap by doing things continuously and not caring if the batches are small, maybe single event or larger. And they've been doing it for ages. And I know from experience, Kafka has a lot of smartness in it, in the clients and in the servers, that really allows the client to do some batching, and it's really based on back pressure from the server. So batch sizes are incredibly flexible. This is also true for Kafka Streams, which I also had a lot of opportunities to work with. So you already have a system that is built to bridge the gap between things that go at different rates. And obviously Kafka, being a large queue, is also built exactly for that. You take this large batch of data, you put it into Kafka, and then you can consume it at your own rate. Kafka was exactly built to buffer this sort of problems. So yeah, it's funny, I said I'm not going to talk about Kafka anymore, that I'm doing a new thing now, but here we are. I think you're always back to the same place because this is where your mind goes. So I hope you learned interesting things about reverse ETL and why is it really hard, but also why it is a pretty cool opportunity. And especially why is it a very cool opportunity if you are a product-led growth SaaS company. So thank you and see you back next week.